So for Chapter 11, Day 4, we are going to continue to talk about ellipses, and the primary focus of the notes today will be to write equations either from a graph or from specific given information. So for example 1, we're asked to write an equation for the ellipse that is given. The first thing I like to do for an ellipse, especially when I'm given the graph, is try and identify the center. So visually speaking, you can see it. The center is at 0, 0. And then from there, one thing we have to remember about an ellipse is in terms of its equation, our A value and B value will be probably the second most important information we should identify. And the reason I say that is A and B in an ellipse are really the distances from the center to the edges of my ellipse. So if I know my A value and I know my B value, one, I'll know, how that is visually represented, but also where those go in our equation. So in this case, if you look at the ellipse, the thing that I notice is that this ellipse is longer or taller or wider, however you want to think about it, in the vertical or Y direction. And A is always the distance from the center to the vertex or from the center to the edge that's furthest away from the center. So in this case, A is going to actually be 5. So that's the distance from the center to the top of this ellipse, and that point up there is actually going to be one of our vertices. And then B would be the distance from the center to the edge in the other direction. So in this case, B would be 3. So now that I know A and B, and my center's at 0, 0, there's really two options for the equation for this ellipse. One of them is x squared over a squared plus y squared over b squared equals 1, or x squared over b squared plus y squared over a squared equals 1. And the major difference between them is where a and b are located. Remember, a is the larger of the two distances and also should go underneath the variable that makes most sense in the picture. So in this case, this ellipse in number 1, or example 1, is taller vertically than it is horizontally. And what that should tell me is that my a value, or my a squared value, should go underneath my y variable. So I can cross out this first equation. You don't have to write both and then cross one out. I just wanted to do that so you can see the major difference between them. Because again, x squared and y squared are just those because the center is 0, 0. Both of them are addition, both equal to 1. The only difference between those two equations is the location of A and B. So again, because A is 5, the longer distance, A squared should be underneath my y variable. So my equation is going to be x squared over 9 plus y squared over 25 equals 1. And again, 9 is my B value squared, and 25 is my A value squared. For the next example, we're going to do something very similar. The only difference here is that our ellipse is not centered at 0, 0. So my center is actually going to be negative 3, 0. And then again, I want to identify my A and B value, especially when I'm given the graph, so that I can begin to write my equation. So A, in this case, would also be 5, and B would be 3. So 5, again, is the distance from the center to the vertex, and in this case, the vertices are going to be at the top and bottom of the ellipse because the ellipse is longer or wider in the vertical direction. So in this case, A will be 5 and B will be 3. And again, where I have to decide to put A and B will depend on what variable they go under. So there's a general equation, standard form of an ellipse, that I would use when the the center is not at 0, 0. So that is x minus h quantity squared over b squared plus y minus k quantity squared over a squared equals 1. And I wrote this as though A was underneath Y because this ellipse is wider from top to bottom, or in the Y direction, than it is from side to side, or in the X direction. So all I need to do in this case is put A and B in the appropriate place and put my coordinates of my center in the appropriate place, and I'll be done. So what I have is x plus 3 quantity squared over something plus y squared over something equals 1. And one thing I want to point out is because the y coordinate of the center is 0, I don't have to write y minus or y plus 0 quantity squared. I can just call it y. So I have the coordinates of my center reflected in my equation. All I need to do is put A and B in the appropriate place. So the number that should go under y should be 25, which is a squared, and the number that should go under my x quantity should be 9, which is b squared. For example 2, we still want to find an equation in standard form for an ellipse, and we're given some slightly different information. So in this case, we're not given a picture, and we're also not given explicitly given the center or the vertex, but we are given what's called our major and minor axis. So our major axis, what that really is the total length or width of the ellipse from vertex to vertex. So again, if A is the distance from the center to a vertex, then the major axis would be twice that distance, or the length across the entire ellipse. And I'll draw a picture to show you what I'm talking about. So we're told the major axis is 6, and again, that would be twice our A value. And the minor axis is actually twice our B value, and B would be the distance from the center to the edge of the ellipse, not in the longer direction. So just to give you a picture, I'm going to add on the x-axis to the end of this so that we're very clear about where the center is. Now, in terms of a center, because the major axis is on the y-axis and the minor axis is on the x-axis, that means my center has to be at 0, 0. So here's how we would use this major and minor axis thing. So again, like I said, 2a is our major axis, which is twice the length of the distance from the center to the vertex, and we're told that that length is 6. So that means A should be 3. And 2b is the minor axis, and we're told that the minor axis is 4, so we can use those lengths, 6 and 4, to solve for A and B. So now we have our center, and we have A and B. We should be able to write our equation for this ellipse. One mistake that people will make is they'll see that the major axis is 6 and think that that is giving you your A value. It's actually giving you twice your A value, and I'll show you what I mean on the picture. So if I plot my center 0, 0, and then A would be the distance I go from the center to a vertex, but in this case it's on the y-axis, so I should go 3 units above and 3 units below, and then B is my distance from the center to the edge of the ellipse, and I should go 2 to the right and 2 to the left. So the equation that I'm going to use, because this is centered at 0, 0, is x squared over b squared, again b squared would be the smaller of the two numbers, plus y squared over a squared equals 1. So because a is 3 and b is 2, I can sketch my ellipse, and it should look something like that. Again, I went 3 units above and 3 units below, and what that gives me is a total length of 6. That's what the major axis is. You can see that on the y-axis. I highlighted it in green. And then the minor axis, the total length from side to side of this ellipse is 4, and I highlighted that in yellow. So that's really what the major and minor axis are telling us. It's telling us the total length or total width of the ellipse, not just the A value or B value. Now, to finish my equation, I just need to put A and B in the appropriate place. So I should get x squared over 4 plus y squared over 9 equals 1. So this example 1 introduced 2 new vocabulary words, major and minor axis, and those major and minor axis should help us find our A and B value so that we can write the equation for the ellipse. For the next example, we are going to write an equation in standard form for the ellipse, and we are given the foci of the ellipse and the major axis endpoints. So the first thing I like to do is kind of put on a graph what I'm given and see how that's going to affect my picture and also how I will write my equation. So again, my foci are 1, -4, and 5, -4, so I plotted those there. And here's one thing we have to remember about ellipses. The center should be exactly in the middle of both the 2 foci and also the 2 vertices. And the foci and the vertices should be in line with one another. So in this case, I plotted my 2 foci. I should be able to say what my center is because it has to be exactly in the middle. So in this case, the center would be at 3, -4. So I have that. So it wasn't explicitly given to me, but I can find my center because it's got to be in the middle of my 2 foci. And now, from that, remember, your foci are a certain distance away from your center, and that distance is our C value. So in this case, each foci point, or focus point, is 2 units to the right and left of center, which means my C value is 2. And that will come into play here at a little bit later in this problem. So I found my center from the middle of my 2 foci. I can also say then what my C value is because it's the distance from the focus to the center on either side. And then we're also told that the major axis endpoints are 0, 4, and 0, negative 4, and 6, negative 4. So if I plot those, again, major axis endpoints are at 0, negative 4, and 6, negative 4. What that should tell me is the length of my major axis. So the length of my major axis would be from the endpoint to the endpoint, which in this case would be a length of 6. So if my major axis is 6, I should be able to use that to find A. And what A is, again, is the distance from the center to the endpoint, or in this case from the center to the vertex, because those two major axis endpoints are also your vertices. So I have my A value. Now in order for me to write my equation, what I don't have is my B value. So I have my center, I have my A, and I don't have my B value, which is what will end up being used to find one of the denominators in my equation. So I need to find my B value, and the way you would do that is using the equation that we usually use to find our focus values, or the focus distance C. So what I have is A squared equals B squared plus C squared, and I know A is 3, so that means A squared is 9. I don't know B, so B squared I leave alone, but I knew that C was 2, so that means C squared is 4. So I'm still going to use that equation. I'm finding B in this case, not finding C, because I actually had C from the original information. So to solve for B squared, I get 5, which means B is root 5. So what that B value is, again, is the distance from the center to the edges of my ellipse in this case would be in the vertical direction. So I got to go root 5 units above and root 5 units below, and root 5 is just over 2. It's like 2.2-ish. So I'm going to plot those points, 2.2-ish, or root 5 units above and root 5 units below. And then I should be able to sketch my ellipse. So there's my ellipse. I have my vertices graphed. I have my center, my foci. All I need to do is write my equation. So my equation in this case is going to be x minus 3 quantity squared over something plus y plus 4 quantity squared over something equals 1. And what I need to do is figure out where A and B will go in this equation. So again, A is the longer of the two distances from the center to the edge, and because A is in the horizontal direction, I should put my A squared number underneath x. So I put 9 underneath x, and then B is root 5, which means B squared is 5, and that's what should actually go underneath my y variable. So in this problem here, we were given the two foci and the two vertices called major axis endpoints, so we had to use our C value and our A value to find B. Now, we could also be given a problem where we're given minor axis endpoints, so that would tell us what our B value is and approach the problem very similarly. So for this last example here, we are going to write an equation in standard form for an ellipse, and we're given similar information, but not exactly the same as the previous example. But the first thing I'm going to do is take the two foci points that I was given, and I'm going to plot them. So -2, 0, +2, 0. And what that should tell me right away is that the center needs to be in the middle of those two foci. So if the center is in the middle of -2, 0, 2, 0, that puts my center at 0, 0. And that also tells me that the distance from the center to the foci, which is my C value, should be 2. So just from the foci's location, I should be able to find my center and my C value. Now the one thing about the major axis, again, it is the distance from the vertex to vertex, or the total length along the longer or wider side of the ellipse. So in this case, we're told the major axis is a length of 10, but the one thing we have to understand is the foci and vertices will always be on the major axis. So because my foci are on the x-axis and my major axis is a length of 10, that should tell me how to find my A value and in which direction I should graph that. So if the major axis is 10, that means that 2A is equal to 10, or A is 5. So what that tells me is I need to go 5 units from the center on the x-axis, to the right and to the left. And the reason I know I have to be on the x-axis is my major axis will always have my foci on them. So I'm going to plot my two A values to the left and to the right, 5 from center. And I just highlighted the major axis in yellow. So my major axis has to be horizontal because my foci are aligned horizontally, and my endpoints have to be, and my vertices have to be on that major axis as well. So I know A, I know C, but again, I don't know my B value. So I'm going to similarly find it by using the equation a squared equals b squared plus c squared. So I know A is 5, right, which means A squared is 25. I don't know B, so I'm going to leave B squared as a variable. But I do know C is 2, so that means C squared would be 4. So to solve for B, I would get 21 equals B squared, or root 21 equals B. And again, what this number is going to represent is the distance from the center to the edges of the ellipse vertically. Because my major axis went from left to right, then my minor axis should go from top to bottom. So I need to go root 21, which is about 4 point something. So again, 16 is, the square root of 16 is 4, the square root of 25 is 5, so square root of 21 is somewhere between 4 and 5. So if I plot those, I would be above and below my center for slightly bit more than 4 units. So I should be able to sketch my ellipse. So it should look something like this. This one appears to be fairly circular. It's not obviously a circle. It's 5 units to the left and right, 4 point something above. But it should look approximately, it's more circular than some of the other ones we've dealt with. Not that that really matters. I just want to point out that it should be closely circular, but not exactly. So now I need to write my equation. So again, I'm going to use the coordinates of my center. So in this case, center is 0, 0, which is x squared over something plus y squared over something equals 1. And then because A is the longer of the two distances from center to edge, and that is in the horizontal or x direction, I need to put a squared underneath x. So A was 5, which means a squared is 25, and B was root 21, which means root 21 squared is 21, and this is the equation for this ellipse from the given information. So in this case, again, I had to use my foci to find my center, and use my center to find my C value, so 2, and then I had to use this idea of what a major axis is, and in which direction the major axis should go, to find A, which then allowed me to find my B value. So to find an equation for an ellipse, the process will really depend on the information that we're given. If we're given the center and information about the major or minor axis, then we can find A or B. But if we're given a picture, we should be able to identify the center A and B directly from the graph. So it will depend on what we're given, but we've covered a few different combinations of given information, so you should have a good start on the homework for day 4.